Welcome to This is Concrete, a podcast where we speak with the people whose work revolves around concrete and coatings. Let's get to what you came for.
Hello, Chad Gill here. I'm the host of the This is Concrete podcast, where I talk with leaders in facilities management, architecture, contracting, and more. Workforce Recon is a sponsor of this podcast. Recon is a project tracking software that connects the office to the field crews. It is built with a field-first mentality, developed by contractors for contractors. It includes time and asset tracking, messaging, job documentation, and scheduling all in one place, so you can see what's going on in the field. So if you're tired of finding out what happened days later, check us out at workforcerecon.com and see your operation in real time. Laminin Coaching is another sponsor of the podcast. Laminin is a business coaching company with a focus on contractors in and around construction. We not only help with proposing solutions and methods, but we implement them in your business as well. After all, good ideas are not useful until they're implemented. So if you're ready to elevate your business, visit us at laminincoach.com to see our full range of services. So joining me today is Alejandro Gomez Rivera, the co-founder of binni, a concrete construction technology company since 2019. He's passionate about civil infrastructure and has spent 15 years delivering complex hydraulic, transportation, and energy infrastructure projects in North and Latin America. He's also a technology enthusiast and a Fulbright Scholar. I think that might be the first one here. Currently, he's developing software solutions to accelerate the adoption of technology in our infrastructure systems with a focus on cast-in-place concrete and mechanized tunneling construction processes. So Fulbright Scholar, I mean, we might as well start there, man. Let's be impressive from the get-go. Thanks, Alejandro. Thank you for coming on.
No, thank you very much for having me.
Yeah, well, I don't have one of those. How did you come across that?
Well, I was born and raised in Honduras, and Fulbright has was created as a way to create understanding between the people of the United States and the people of everywhere else in the world, right? So there's a component in which you give scholarships to U.S. students to go do research abroad, but there's also a component that gives scholarships of student abroad and brings them to U.S. universities, and mostly for grad school. And I was lucky to get one of those and live for 2 years in Boston a couple of years ago. So
What school did you go to in Boston? There's a couple of fairly well-known ones there.
yeah, it's called Northeastern University.
Oh yeah.
In Boston. Yeah. So I spent 2 years there, and then went back home, continued building, continued doing work in construction, and then I really discovered so many fields that really got me really passionate. And so I decided I wanted to go back to school. And so years later, when I paid my dues, which was go back to my home country and live there and apply my knowledge for 3 years, I was then released and I could go back to school, and I moved to Pittsburgh at that time. I've been in the US since then.
Oh wow, that's fantastic. And where were you in school in Pittsburgh?
It's called Carnegie Mellon University.
I was afraid you were going to say that. Yeah, I would pursue Carnegie Mellon's Robotics Institute. That's a tremendous school. I like how you just dropped Northwestern and Carnegie Mellon, like, oh yeah, these little known places. That's fantastic, man.
Well, I mean, imagine, to me, it was Northeastern was unknown before I came here, right? I came here, I had no idea the weight that Fulbright and these schools had until I came here, and I went into those places, and then I realized that all of a sudden life had given me some kind of spectacular opportunity to be part of these amazing institutions and be surrounded by these truly amazing people that are part of these places, right? But and then learning a lot about computing, that's where I learned most of what I know about computing, robotics, data analytics, and all these kinds of things that I'm really passionate about. But we're not seeing enough in construction, I think, yet.
So tell me a little bit about that. Like, so what are you working on now as far as implementing those?
Well, I started binni. I co-founded binni. We are a construction technology company, and we're supporting concrete and tunnel construction contractors. After I spent some time in Pittsburgh, I moved to DC. Before that, I had worked in construction of bridges, highways, heavy civil mostly, right? Dams. And then I moved to DC to work as a tunnel engineer. So I was working in these tunnel boring machines, digging huge tunnels under DC. And I found out that construction in general was the way that we manage construction projects were not very different in the US in these massive, impressive projects than what it was in the smaller projects that I was working on in Central America, right? So at the same time, I had been coming from these other places where you would see robots roaming around the hallways of the, where you were going around. And so you see these two worlds so far apart that, well, you say, okay, there might be something out here. Let's experiment and let's try to do something here. And regarding concrete, what we're doing is the idea behind binni is that for construction teams, it shouldn't be so hard to communicate with all the participants of the concrete construction operations to get all the details of the operation. Or think of the ready-mix suppliers, the field and the lab QC, labs, the sensors, and even internally, right? Just the management, the construction, the office teams, just the exchange of information between all these participants. It's too complicated. I think that for contractors, it should be as easy to communicate with different ready-mix suppliers, for example, as it is for all of us to travel using Expedia and communicate simply with 10, 12 different airlines and hundreds of different hotels, right? So it should be as easy for contractors to communicate with their partners. And so that's what we're trying to do. We are building a communication network that connects the entire value chain of concrete in a way that can simplify and can streamline how all the information flows across the different processes. Right now, the way
is that like mixed
sorry.
all the way through purchasing of concrete and delivery and sump tests, and then ultimately hardness checks and all of those?
That is correct. So right now, our platform helps plan, track, and report the entire pipeline of concrete pours on a job or for a company, right? So we break down every pour, or our clients break down every pour, and within every pour, they can specify who's the responsible in case there's more than one responsible organization, like different subcontractors on a job or things like that, or who's the supplier for each of those pours, which makes design, and then they're tracking it from look ahead schedule. So the pours from 2 weeks ahead of time, all the way to the last lab test results, and keeping all this information organized, keeping all this information available in real time, synchronized with the different participants. We have projects, for example, who have 5 different suppliers, and instead of having to be opening 5 different apps to know which is a supplier for which pour that's going on, they go to a single interface, where that single interface helps you communicate with all the different suppliers that are part of that job, right? All you do is give us the order that you place with that, the order ID, and we'll communicate no matter who your supplier is.
So it's ready mix plants, it's structural engineer. I mean, who are all the different components or people that are looking, and who actually, like, I guess who's software? I mean, I don't know. I guess I'm wondering who is
Who's our client?
Yeah, who's your client? Is your
Yeah.
client the GC or the owner, or who is it?
Yeah, so it's the general contractor, more often than not, and we're also walking towards the owner being our customer, right? So and sometimes it's been both. We've had projects where both the general contractor and the owner have become the client, and they've been collaborating, and they've been working together using the same platform. And then with that, they put us in touch with their partners, and that being the ready mix suppliers. Now that we're using more sensors in concrete for maturity or for mass concrete, we're also connecting our clients to their sensor suppliers and to their sensor data, helping them share the data that's being generated by those sensors, and tied with all the e-tickets from the ready mix suppliers and the field QC data that's generated by the field QC team. And then later on, we also have integrations, for example, with labs or brake machines, that as soon as a cylinder is broken, that result can flow, and it's traced to the specific delivery and the specific pour where that cylinder came from, right?
Okay.
So we're doing all those connections from all these different organizations that make part of a concrete pour or pipeline of concrete pours.
What type of, when you talk about sensors in concrete, like what are you seeing as a lot of the sensors that are going into concrete these days?
Mostly temperature, right? Mostly these are being used on mass concrete to monitor, as part of the program, to monitor mass pours, where they have to measure or monitor the differential in temperature between the core of that mass and the edges doesn't exceed certain amount, because it might create some micro fractures that could compromise on the long term the integrity of the structure, right? So it's just part of a plan to do things like that. And then these same sensors can now be correlated to the strength, or to what's the strength of that concrete at any given point in time, and they're being used as maturity meters, and especially in vertical construction, they're being used a lot to decide whether you're gonna remove forms or not, right? So those are the two main uses that we're seeing out there on the use of sensors for concrete.
So when you talk about mass concrete, you're talking about something that's very thick. Is that typically
Yep.
important?
Yeah, I think mass concrete is defined as something where the shortest length is 3 feet, right? So any geometry that is at least 3 feet long on any of its sides would be considered a mass concrete.
So if you do get a high temperature on the inside of a mass concrete, how do you, I mean, unless you've got an internal cooling pipe or something, how are you going to, what do you do?
There are methods people use, well, from cooling pipes that are used a lot in dams, for example, or locks, or these other more massive structures, to having plans to blankets, curing blankets, and covering and uncovering, and you got to have people working to do these kinds of things depending on what are the readings. Right? So it can be as simple as that, or as complicated as having cooling pipes.
So that's on the placement of concrete, like concrete, the typical concrete, but also you have a tunneling application as well, right?
Yeah. We also with the same concept, with the concept that nobody really understands the actual performance of a product or an operation unless you can bring together information from multiple parties. we have applied the same concept to tunneling operations, where you have tunnel boring machines. Think of these 20, 30, 35 feet diameter machines that are going under cities. There's lots of information that's being generated underground by people looking, taking pictures, and specifying defects or specifying the reasons for downtime when it comes to productivity. But also lots of sensors are being placed, not just on the machine itself, which can have 2, 3, 4,000 sensors generating information every half a second.
I thought you were gonna. I was thinking you were gonna say 2 or 3.
No. We're talking about pressures, flows, and all kinds of things that are being measured in these machines. But at the same time, you're also putting sensors on the buildings and all structures and on the ground above where that machine is excavating. So that as the machine is going and as the machine is excavating, you're monitoring that you're not moving the ground, or that you're not moving any of the existing structures above, and make sure you're not causing any damage, right? So part of what we brought in, kind of as a new concept, as a concept that didn't exist, is also this concept of bringing everything together and be able to overlay the information that's being generated by a company that's instrumenting above ground, and the company that's manufacturing the machine, and the people who are generating information manually, right? So we're bringing all this information together and helping them understand, cause effect. What are the operating decisions that are being made that are causing the movements that we're seeing, and that way reducing the risk of damage or of safety issues that could come out of these movements, right? So those are the kinds of things that we're bringing into the world of construction. These two things.
Yeah, I know. Just picture the idea of a 20-foot drill rolling through bedrock underneath an apartment building, and you're like, you would like to know that you're not shaking it more than you're supposed to.
When it comes to bedrock, it's not that worried, because you're on bedrock. It's more when you're on excavating on soft ground, when you're excavating in clay or sand, where the control of the pressures and all these kinds of things. It's a fascinating process of construction. Very, very delicate. Imagine these huge machines, and then you get to a point with a 4 millimeter precision, right? Oh
my gosh, it's
pretty amazing.
That is crazy. And then are you boring and then casting concrete right behind the machine to encapsulate the tunnel, or how do they do that?
So these are prefabricated rings, and these are rings that are built in sections. So think of a Lego piece, that you're inside the machine. You have a robotic arm that grabs each piece and puts each piece around as the machine is moving. And so the way it works is you have the machine with hydraulic jacks supported at the edge of these rings, and then contracted, right? And then it starts excavating. So the hydraulic jacks start expanding up to a certain level. And then when you reach that level, you stop, you retract those jacks, and then you put the next ring. And then you do the same thing. So you repeat. So it's a cycle of advancing, building ring, advancing, building ring, advancing, building ring.
Almost like vertically, the way they put together a tower crane. Stacking it and bringing in a link and stacking it, and
Yep, exactly.
Yeah, that is, and we've been building tunnels for a lot longer than we've had that kind of technology. That's that's crazy.
And that's when you see that argument that you hear a lot out on the street, that construction is not innovative. It's totally false, right? Whoever has been in construction sites knows that when it comes to hardware, when it comes to cranes, when it comes to all kinds of machines and tools, there's tons of innovation that has been going on, right? But there's still opportunity to work and innovate better in how we communicate information on the management side of construction jobs.
It is funny. You would think that, two places I always look and think that, technology should have had the biggest impact was construction and education. And it seems like those are two places, that just like you said, there's lots of innovation. It's just not in the software technology side typically. I mean, it's coming now, but,
It is. But I don't know what's your impression on that, but what we have seen is that the same reason why it's hard to communicate, it's the same reason why it's hard to innovate, and that's because of the dynamics of how we build, right? We have one subcontractor for these, one lab for that, especially when just focusing on concrete, right? We have a subcontractor or several subcontractors, and we have an independent lab and one or many ready-mix suppliers and one or many sensor suppliers. And so for something to work, you have to convince everyone to participate on it, right? So, and then who pays for it, right? So the dynamics of the client. And so that's where the complication of innovative in communication technologies in construction comes. This is the main reason why it's hard to innovate in that space. It's because of the fragmentation of teams and people who are responsible for different things, right? So
yeah, it's and there's always a cost component to it. It's like I forget, I don't remember the actual thing. They're like, the space shuttle was built like it's 61,000 parts or something, built by 2,700 lowest bid contractors or something. But it still does what it's supposed to do. It's an amazing coordination dance.
It's actually impressive. I mean, I don't think people who are not part of construction projects miss the point of how complicated it is to get all the pieces together at the right time, and doing it right at the first time, right? And repeating it over and over in the right way. It's really, really hard to get. You're also, as you're working, you're also dealing with the environment, the weather or neighbors. And all these kinds of things makes coordination so complicated. And that's where a lot of the improvements on construction management need to come from improving communication. But at the same time, it's really hard to do it.
Yeah, it is. And then you got to do it across multiple platforms, multiple technologies, multiple languages, multiple countries. It's the world's getting smaller.
and so that's what we're focusing all our efforts. So right now, for example, binni is a platform, right? So it has a front end and a web app and apps where people are doing these things, but because we're showcasing what it is to bring people together. But in reality, what we're doing is behind the scenes is creating these communication channels so that any other construction technology platform can access the same network through a single endpoint, right? So it's not just about feeding a platform for binni, it's about feeding the industry and all the different technology platforms. And we're just focusing, like, I'm gonna say this, tunnel focused in concrete. Just there's a lot of complexity there, enough complexity to require full attention.
So you're focused, so you'll still connect with, like, say, a Procore or a Builder Trend or any of those kind of things. That information will transfer over and interact with those as well.
Exactly. So the whole concept is this is just one activity that requires more depth than most other activities that you have on construction projects. But at the end, it needs to flow to the overall project controls, right? So yes, that is part. We're just a translation layer between all the details that happen in construction and an aggregator of all this information so that it makes sense at the overall project structure throughout
That's
the overall project controls.
sounds like you've bitten off quite the project.
It is, but it's been fascinating to see. You know, we've had at this point projects valued in over $10 billion. You know, people building those structures using these technologies on a daily basis, right?
Wow.
So it's just a you know a proof that people are actually having issues out there communicating all the details that are required to build, and then to show an owner that you have complied with everything that you should be complying, right?
Yeah. No, that's man, that is fascinating. Well, I appreciate you taking time to kind of tell us about it and show it. And so the website is binni, binni.co, correct?
That is correct. Yeah.
Absolutely, good deal. And yeah, it's great. I'm looking at the page, and the interface looks super simple, which is fantastic. That's what we need in the field. You know, something you can do with one eye closed and a glove finger. So yeah, I mean that. It looks like you guys are on the right track, and you know, I applaud you for it. It's a good application and data that we need to help us build better.
Thank you very much. Thank you very much. It's been quite a journey, but we do it with enthusiasm.
That's right. That's right. What is it?
It's a painful journey too. You know, this journey of bringing new things to construction is quite difficult.
I'm telling you, software creation and new type. I mean, you put that's two of the hardest things you can do, and then you're going to do it again. That's perfect. Yeah, I've got I have a few lumps on my head from doing that as well, so I understand. Yeah, but that's great. But yeah, fantastic. So thank you very much, and look forward to catching up with you again soon and seeing how it's going on one of these projects.
Thank you for having me.
Thank you. Bye.
Thanks for listening to This is Concrete. We look forward to you joining us next time. Be sure to click subscribe to get future episodes.